Hi, welcome to my video on the inverse of a parabola part 2. Number 1, f of x equals x minus 1 all squared minus 2. This is a parabola, and the vertex of the parabola is the opposite of negative 1, which is 1, and a negative 2. So if you put a 1 in here, you'll get a 0, square root of 0. So when you put a 1 in, you get y is negative 2. And because there's a positive here, that means the parabola is opening up because of the plus. And also, looking at that, we can also say that the range is, because this plus is opening up, so the range is greater than or equal to negative 2. And as in all parabolas, the domain belongs to the reals in all parabolas. It says find f to the negative 1 of x. That's the inverse. So change the f of x to a y. Now we have to switch the y and the x's. So I'm switching y to x and x to y because the reflection in the line y equals x. Now I'm going to solve for y, so we have to move the minus 2 over to make it a plus. And now we have to do the square root, so it's plus minus the square root of x plus 2. And the square root of y minus 1 squared is y minus 1. And so y is equal to plus minus the square root of x plus 2 plus 1. And so the inverse, f to the negative 1, f to the negative 1 of x, that's a negative 1 right there, is plus minus square root of x plus 2 plus 1. So this says graph the f of x and graph the inverse. So let's graph the f of x. So the f of x has a vertex of x is 1, y is negative 2. X is 1, y is negative 2. So let's go with a 2 and a 3 and a 0 and a negative 1. Take a 2 and plug in here. You get 1 squared is 1. 1 minus 2 is negative 1. So this is a negative 1 here. Put a 3 in. 3 minus 1 is 2. 2 squared is 4. 4 minus 2 is 2. So this is a 2. Once you get these two, it's symmetrical, so I don't know what these are. So the inverse, which I could say, the inverse is, let's use the red for the inverse. The inverse is the x's become the y's, so it's a 3, 2, 1, 0, negative 1. And the y's become the x's, so 2, negative 1, negative 2, negative 1, 2. Okay. Now, let's graph the original f of x. So the vertex is 1, negative 2. X is 1, y is negative 2. So when x is 2, y is negative 1. When x is 2, y is negative 1. When x is 3, y is 2. When x is 3, y is 2. And on the other side, 0 gives me a negative 1. 0 gives me a negative 1. And a negative 1, 2. Negative 1, 2. So you can see the vertex and the parabola is symmetrical. Like that. You can see that the axis of symmetry is straight down through at x equals 1. So this is the parabola. Now we graph its inverse, and the inverse is the reflection in the line y equals x. This is the line y equals x. So I'm going to do the inverse in red. So we have right here the vertex. So we can graph, if we take the vertex, this is negative 2, 1. X is negative 2, y is 1. And we take negative 1, 2, negative 1, 2, and we go with 2, gives me a 3. 2 gives me a 3 right there. And on the other side, negative 1 gives me a 0. Negative 1 is a 0. And 2 gives me negative 1. 2 gives me negative 1. Okay. Make sure. Did I say negative 1 gives me a 0 and I put it right there? No, there it is right there. And 2 gives me negative 1. I thought it was off a bit when I put it there because so red is the inverse. This point right here, just want to cover that little bit of red up there. So there's the inverse. So, oops, this is f to the negative 1. And this one right here is the f of x. So the domain of the f of x, is x belongs to the reals. So this is the f of x, the parabola. Domain is real, and the y values are greater than or equal to negative 2. So that means that the inverse, the domain is x and the range is y, but the range becomes the domain. So that's x greater than or equal to 2. And this is the domain of f of x, which is the range of the inverse. Again, notice that this is going up, and I'll do that reflection for you just to show you what I did before. We had a previous grid, and I just want to show you this. We had a previous grid. This is not exactly the same as this one, but notice it's going up. So when I reflect in the line y equals x, which is right here, so I take it and I flip it over, and I put it down, and there's this inverse right there. So what I'm trying to say, or get at, is that if this is moving upward, then the inverse is going sideways, going to the right. Okay, keep that in mind. And we continue. I had to do a new page because I didn't want to like condense everything into one page. It makes it so. This is what I have on the previous page. So notice I have f of x, which is this right here. This is the f of x, and this is his inverse, plus or minus. This is his inverse in red right here. So I redrew the grid and the reflection in the line y equals x is right there. That's the y equals x. Now, what I want to do is look at the parabola, but I want to look at the right side. X is greater than or equal to 1. So what we have is that we have a domain and a range, and we have the f of x, and we have f to the negative 1. So the domain of the parabola is reals. The range is y is greater than or equal to negative 2. So the inverse has x and y. Is x is greater than or equal to negative 2, and y is belonging to the reals. But in this case, what I have x is greater, instead of having the main one, I now have this condition. So instead of being just reals, I got x's greater than or equal to 1. So instead of having reals, I'm picking the right side. So that means that we change this. This is greater than equal to 1. So notice when we have x is greater than or equal to 1, which is the values of x being the right side. Now the range is still going up because that's a plus. It's going up from the -2. So we switch it. X is greater than or equal to -2 and y is greater than or equal to 1. So if you look at this side, so this one is right here. So this is the piece we're looking at, the right side. So we have this and this and so these are the points right here. So I draw this. So this is the f of x. Now I'll do its inverse, and its inverse is x is greater than or equal to -2, and y, so is this one. So the inverse is 1 x's, just to make sure, x starting at -2. So -2 gives me a 1, there's that one. -1 gives me a 2, which is that one. And this point here is 2 gives me a 3, so 2 gives me a 3. So there's the inverse in red. So this is f to the -1 of x. And in relation to the inverse, it's f to the -1 of x. And notice the y values right here, x is greater than or equal to 1, but the y's are positive, so it's root of x plus 2 plus 1. It's the positive one because the y's are greater than 1, so that means it's the positive one. So the inverse of this parabola is plus or minus, made up of the right side and the left side. But now, because we restrict the domain, x is greater than 1, then y is going to be, the y values are going to be greater than or equal to 1 on the restriction. So that's the plus there. So this is the one that indicates, the plus indicates this side here. So if we take the table of values, which is -2, 1, and put it in here, it'll make it true. If you take this point, which is x is -1, y is 2, put a -1 in here, I get a 1, square root of 1 is 1, 1 plus 1 is 2. So this plus is the upper side. The right side of f of x is the upper part of the inverse. And this is also true when we do the other side. So if we have the f of x and f to the -1, then we want to find what this is. So this is f to the -1, and we look at the domain and we look at the range. The domain is x. Instead of the domain being the real numbers, we now restrict it to the left side, and the range is y is greater than or equal to -2. So in the inverse, x and y, so y is greater than or equal to -2, so x is greater than or equal to -2. So the domain here is the range here, so x is less than or equal to 1, y is less than or equal to 1. And because we have, and again I could put it in red or black to make a difference, we have the negative of the root of x plus 2 plus 1. So again, y is less than or equal to 1, so that means we have the negative. Y is greater or equal to 1, we have the positive. So the parabola is the left side. So this is x is less than or equal to 1, it's this side right here. So we got 1, -2, and we have the other vertex is, this is the vertex here, the other point I meant to say is right here, and we have -1 is a 2. Okay, there it is there. So it's, what we're drawing is this piece right here, taking this point, this point, and this point. So there's, notice this is the f of x, Notice because x is less than or equal to 1, it's the left side of this parabola. And the left side of the parabola is going down. So that means it's the vertex is same as here. This vertex is transferred, switched around. So 1, negative 2 becomes negative 2, 1. So it's negative 2, 1. And this other point is right here. We take this point is x is 0, y is negative 1, so it becomes negative 1, 0, which is here. This point here is negative 1, 2, so it becomes 2, negative 1, which is right here. So the parabola is, half of the parabola is doing this. And so this is f to the negative 1, and this is the f of x, so they're the inverse of each other. So it's half the parabola that I'm trying to explain to you. Hopefully that makes sense. And we have another one to do to make sure. Always good to do too. What about if the h of x equals negative x squared plus 3? Again, it's a parabola. The vertex of this parabola when x is 0, y is 3. Because it's negative, the parabola is opening down. And again, this is a parabola, so your domain is real numbers. And your range is, this is going down from 3. So y is less than or equal to 3. So let's find the inverse of this. So the inverse, h to the negative 1, the h of x becomes y. We switch to y and the x. And now we solve for y. So x minus 3 equals, subtract negative y squared. And we do multiply by negative 1. So we get a y squared, negative x plus 3. And so we do the square root of y squared is y. And this is plus minus the square root of negative x plus 3. And so its inverse is h to the negative 1 of x. The inverse is plus or minus the square root of negative x plus 3. Now, let's graph the h of x and its inverse. So the h of x is right here. The vertex is 0, 3. I'll put the vertex of 0, 3 in the middle. So I'll take a 1 and a 2 and a negative 1 and a negative 2. So I'll plug 1 into this equation. X is 1, plug 1 in. 1 squared is 1. The negative of 1 is negative 1. Negative 1 and 3 is a 2. So I'll plug 2 in, sub 2 in. I square first. 2 squared is 4. The negative of 4 is negative 4 plus 3 is negative 1. And so this one is a 2 and this one is a negative 1 because it's symmetrical. Now, if we want to do the h of x, which is his inverse, so there's, I could mark h negative 1 of x like that, and this would be his inverse. I do it in red. The x's become the y's, 2, 1, 0, negative 1, negative 2, and the y's become the x's. Just takes a while to get used to. Now I'll graph the h of x. I'll do its vertex first. 0, 3, x is 0, y is 3. Okay. And now I have its vertex done. 1, 2, x is 1, y is 2. X is 2, y is negative 1. X is negative 1, y is 2. And x is negative 2, y is negative 1. And again, notice the parabola is symmetrical. Vertex. So notice the axis of symmetry is x equals 0, symmetrical. So as you move 1 to the left or right, you get the same y value. As you move 2 to the left and right, you get the same y value. So this is the f of x. So I'll do its inverse in red. So the inverse, let's go with -1, 2. X is -1, y is 2. X is 2, y is 1. X is 2, y is 1. X is 0, y is 3. X is 0. Sorry, x is 3, y is 0. X is 3, y is 0. X is 2, y is -1. X is 2, y is -1. X is -1, y is -2. X is -1, y is -2. Right here. So there's his inverse. And this is f to the -1 of x. And you notice that it's going down, and if you take the parabola that's going down, and let's see, here it is, I got one previously done. So here's the parabola that's going down, reflected in the line y equals x. Just turn it over, and notice it's going this way. Notice that the y's are going down. So if the y's are less than, that means the inverse is x. If y is less than, the inverse is x less than. Yes, it makes sense. The x's are going to the left. Okay. So the h of x, the domain is x belongs to the reals, and the range is y is less than or equal to 3. We did that. So its inverse is x and y. So the y is less than or equal to 3. So x is less than or equal to 3. And x belongs to the reals, so y belongs to the reals. So notice h of x, which is, oh, I got an f there. I'm so used to doing f's, I sometimes change it. Okay. By habit, I put f. I'm always doing the f's. So this is the h of x. This is the h. So if you see me put an f in just by ear. So notice the parabola is going down, and it's all the x values. So this, the inverse, this is going left. So notice. Okay, and as in the previous one, I redid the diagram and wrote down the two equations with his inverse in. But this time, we're doing D based on this. So notice that we have domain, we have the h of x and the h to the -1 of x. Domain, range. Notice instead of the domain being all real numbers, it's restricted now. We're talking about x is greater than or equal to 0. And so that means that the y is going to be going down from 3, so it's less than or equal to 3. So the inverse is x and y. So the y is the x is the y, because they're switched. Domain is always the x, range is always the y. So less than or equal to 3 goes right here, greater or equal to 0 goes right here. So that means the inverse, h to the -1 of x, because the y's are going up, that's going to be the positive of, we have a plus minus, but on the right is the plus. Okay, so let's look at we're looking at this parabola here, so we're looking at this side right here. So we got 3, 0, or sorry, x is 0, y is 3. this is x is 1, y is 2, x is 1, y is 2. And this one was x is 2, y is, right here, negative 1. X is 2, y is negative 1. There it is. This is the f of x. So again, notice that this is the parabola, and because we're saying x is greater than or equal to 0, we're taking the right side. And there's the right side. So if we take all these ordered pairs that I have here and swap around, then you'll get the graph of its inverse. So 0, 3 becomes 3, 0. 1, 2 becomes 2, 1. And 2, negative 1 becomes negative 1, 2. So there's his inverse. And it's h, gotta be careful. I'm going to put an f there then. And right here, see, I did an f again, so this is an h. Oh, this is an h, not an f. Just a habit I get. I use f all the time, but I decided to do this one in terms of h. And again, notice that this parabola is on the right side, and the right side is above. So that means the y's are greater. So there's his inverse right there. So if we take these ordered pairs right here, these ordered pairs, and take these ordered pairs and plug it into this equation, it should make sure that you have the plus. So 3, 0, put 3 in, you get a 0. Take this one, which one did I take here now? I picked this one right here, covered it up a bit. So this is 2, this is 2, 1. So you put a 2 in here, x is 2, so that's 1, square root of 1 is 1, so that's true. If we take this one, which is negative 1, negative 2, negative 1, the opposite of a negative 1 is 1. 1 plus 3 is 4. Square root of 4 is 2. So negative 1 gives you 2. So this is a plus. Okay, so now we got, that's the right side, which is going up there. Now we have x is less than or equal to 0. So we have the h of x, and we got its domain, and we got its range. So x is less than or equal to 0. And y is, again, y is going down, so let's do his inverse, and again I'll put the h to the negative 1 here this time. So this is x and y, so the y is the x, and the x is the y. So let's graph the h of x. The h of x is right here, this side, so we get 0, 3, we get negative 1, 2, and we get negative 2, negative 1. Negative 2, negative 1. This is the h of x. Again, notice this is x is less than or equal to 0. It's the left side. And the left side is going to be the one going down. So notice, if we take this one, so we do the inverse of 0, 3 is 3, 0. The inverse of negative 1, 2 is 2, negative 1. And the inverse of negative 2, negative 1 is negative 1, 2. There. There's his inverse, h to the negative 1 of x. And again, notice, according to x, according to this, x is less than or equal to 0. That's going to the left. Y is less than or equal to 3. So x is going left and y is going down. There it is there. And the inverse, x is going to the left of 3. And y is going down from 0. So you're going to the left of 3 and going down. So there's his inverse. So hopefully you'll understand what's happening here. And now we have a final question. I always come up with some extra questions. Helps you use your math skills. F of x equals x plus 1 all squared minus 4. Notice that's a parabola. And the vertex of the parabola is -1, -4. But the point 4k, comma k, is a point on the inverse. Find the coordinates of the points on the f of x. So I got two choices. So this is the f, and this point lies on its inverse. So if this point lies on its inverse, that means that k and 4k lies on the f of x. Because if we have 2 points, and if you have two functions and they're the inverse of each other, then the coordinates of the points are switched. So if this was 10, 1, this would be 1, 10. So we have 4k and k, so now we have, this is the x and this is the y on the f of x. So if we take the f of x and make it a y, like this, then this is the point that's on the f of x. So this is the f of x is here. So the y is 4k and the x is k. So now we have an equation in terms of k instead of terms of x's and y's. We have the same variable. So we take the 4k, square this. So we can do FOIL or square binomial. We square the first term. We get the product, 1k doubled. And we square 1 plus 1 minus 4. So that becomes 4k equals k squared plus 2k minus 3. Now I can move the k to the left, but let's move it all to the right. K squared plus 2k minus 4k minus 3. We got a k squared minus 2k minus 3. And this is a quadratic, hopefully it's factorable. Makes it easier. K and k. Factors of 3 are 3 and 1. The product is -3, and the sum is -2, because there's a 1 here. So the factors are 3 and 1, but the product is negative, so I have to have a plus and a minus. So because the sum is -2, then I have a -3 plus 1. Multiply -3 by 1, you get -3, add, you get a -2. So that means k minus 3 is equal to 0, or k plus 1 is equal to 0. K is 3, or k is -1. So we got the f of x. We want the points on the f of x. So the f of x has the coordinates of k, comma 4k. So that means if we take k to be, so if k is going to be 3, so we have a 3 and a 4 times 3. So that means we have 3 and a 12. So if k is -1, so k is -1, and we got 4 times k, 4 times -1, so we have -1, -4. So these are the two ordered pairs that would lie on this point. So if we take these ordered pairs and reverse them, so if you took f to the -1, then the points would be 12 and 3 and -4 and -1. But so this is the points when you flip them. So it was easier to change this point around x and y around here, because I already have the f of x. Switch these ordered pairs, and now I can plug them into the f of x. The longer way would be to work out the inverse, f to the -1, by solving this and then plugging in those points. But it's easier to switch those points and plug them in here to get the answers. So that brings us to the end of the video. And if you like my video, click the like button. If you're not a subscriber, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content that's on my YouTube channel called Math Fully Explained. Notice all one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.